Okay, so this is like the fifth time I'm trying this, and I'm going crazy. That's all right. Here's a quick recap. There's this guy, Tyler, and he's at a ticket booth at an amusement park, and he starts walking toward the bumper cars. You guys remember the story. Now, the point on the graph shows his arrival at the bumper cars, okay? All right, now I want you all to take a look at this table over here, okay? The X side is on the left side. The Y side is on the right side. What do the X's represent? Like, what's the topic, okay? Look at the Y side of the table. What does that represent? I'm not talking about the numbers. Like, what's the actual topic here? Okay. Now I want you to look at the graph. Here's the X's. Here's the Y's. It should match the table. Okay. All right. Now, one thing I want to point out is that the rule for the table is that all of the X values are being multiplied times 1.25 to get the distance in meters, the Y side, okay? All right, how did we get that? Well, it's really simple, and it's gonna follow the same pattern no matter what the graph or table is about. You're gonna take your Y number, and you're going to take the matching X number from the table, and that is how you would set up a rate. Okay, in this case, let me make this red so it pops a little bit better. Okay, so in this case, you can pick any, that should be an X. Okay, so in this case, you could pick any Y value from the table. You guys name it. Let's go with 25. So when Y is 25 for 25 meters, Tyler has been walking for 20 seconds. Okay, all right. So now in order to figure out that the rule is 1.25, what you do for any rate set up like a fraction is you divide by the bottom number. By the way, the X number always goes on the bottom. So 20 divided by itself, and that's equal to 1, okay? Now, whatever you do to the bottom, you gotta do to the top. So 25 divided by 20 is equal to, and that's actually gonna equal 1.25, okay? All right, I'm gonna go ahead and scoot this over so that way we have some room over there. All right, so that is how we got the constant of proportionality 1.25. And we call it the constant of proportionality because it's constantly showing up in the table, times 1.25, times 1.25, times 1.25. That's why we call it the constant of proportionality, okay? And by the way, that's just a fancy word for unit rate whenever you have 1 on the bottom. All right, let us continue, shall we? All right, let's do this. Okay, so same situation, and our question is, what does the point 0, 0 mean in this situation? So let's analyze this, okay? 0 represents the X number, so in 0 seconds, right, he's traveled 0 meters. And that should make sense because if you haven't started walking yet, then you aren't going to go anywhere, right? So at 0 seconds, Tyler traveled 0 meters, and that's what the point 0, 0 stands for, okay? Moving on. Guys, same situation, okay? It says, how far away from the ticket booth was Tyler after 1 second? Now, we already figured that out on the other slide. It was 1.25 seconds, and we got that by choosing a Y value from the table, and then the matching X value in that table was 20, okay? So you set up your fraction, Y always goes on top, X always goes on the bottom, and to find the unit rate, you always divide by that bottom number, and that's how we got 1.25 over 1. And that's just a fancy word for and then constant of proportionality is just a fancy word for unit rate, all right? So back to this question. How far away from the ticket booth was Tyler after 1 second? Well, he was 1.25 meters, okay? Okay, now they said label the point on the graph that shows this information with its coordinates. So if we look at for 1 second, okay, looks like it takes 2 squares to get to the 10. So 1 square would be worth 5, and 1 would be like over here. So this is going to be a tiny dot. Same thing over here. These are going by 5. So 1 and 1.25 is going to end up being like in this area, more or less, okay? And I don't want to get too picky with that because it's going to be hard to mess with, but it should be about right there, okay? And all we got to do is just label it. That's 1 and 1.25. Okay, 1 second of walking, Tyler traveled 1.25 meters. Okay, there we go. All right, let's continue. All right, new scenario. Water runs from a hose into a bucket at a steady rate. Now the amount of water in the bucket for the time it is being filled is shown in the graph right there, okay? Problem one, they say the point 12.5 is on the graph. What do the coordinates tell you about the water in the bucket? So if I look over here at this point, this is the point 12.5, okay? Now, this is called an ordered pair, by the way. Points are called ordered pairs because it goes in alphabetical order. In the alphabet, X comes before Y. So your X number is 12, your Y number is 5. And let's just look at what that represents here. At 12, you go sideways 12. That represents 12 seconds. And if you count up 5 spaces, 1, 2, 3, 4, 5, that represents 5 gallons of water. So in 12 seconds, the hose fills that bucket with 5 gallons of water, okay? All right, now question two, how many gallons of water were in the bucket after 1 second? So if I look over here on the seconds, at 1 second, go up right there, the line is about right there. And let me bring this just a little bit lower. So at 1 second, it looks like it's between 0 and 1, about halfway there. So it looks like it's about half a gallon of water, but we can actually find an exact answer using the coordinate, okay? Now remember, the way we set that up, you're going to set up your fraction. The Y number goes on top. In this case, it's 5 for 5 seconds, okay? And the X number goes on the bottom. So I got that wrong, actually. 5 stands for 5 gallons. Okay, so for 5 gallons, it took 12 seconds. And in order to figure out, okay, how many gallons of water were in the bucket after 1 second, you're going to divide by the bottom number. 12 seconds divided by 12 is equal to 1 second. Whatever you do to the bottom, you got to do to the top. So 5 divided by 12 is equal to, and let's just see that, okay? So order matters. The 5 came first, so that goes first in the calculator. 5 divided by 12, and that was 0.416. We're going to round this to the nearest hundredth. In other words, to the second digit after the decimal. To round it, I got to look at the number in back of the 1, right? So that's a 6. 6 is bigger than 5. And so if you think back to how we round, if it says 5 or more, raise the score, that just means round up. So we're going to add 1 more. So instead of 0.41, we're going to have 0.42, right? 41 plus 1 is 42. So 0.42. It's pretty close to 0.50, which is like half of a gallon. So our estimate that it's about half of a gallon in the bucket after 1 second is pretty close. And by the way, this must be like a firefighter's water hose, because like 1 second, you already got half a gallon. That's like the little half gallons at the store for milk. Like that's a lot in just 1 second, right? So anyways, that is that's the amount of water that would be in that bucket after 1 second coming out of that water hose. Okay, guys. Next part right here, we're going to be using graphs to compare proportional relationships. If you look at the lines, these are lines that represent proportional relationships because they are straight lines. They're not bent. Yeah, they're diagonal, but they're straight lines though, right? And they both go through 0, 0. Here's a scenario. The graph shows the price of different lengths of 2 type of rope. My favorite topic. Right, okay. Now, if you buy $1 of each kind of rope, which one will be longer? And explain how you know. I like this because there's no numbers on this graph, but we could still analyze it. And that's what we're going to do. Guys, I want you to look at this picture. It's the same situation. I know the background isn't green, but it's the same situation, okay? Now, guys, look at this. The nylon rope would be longer, and here's why. For $1 right here, you go up here's $1. I'm going to go sideways. At this point, this represents the length of rope of cotton that you could get for $1. At this point right here, this represents the length of rope of nylon that you could get for $1. And if you look on this line right here for meters, okay, even though there's no numbers down here, I know that the further and further I move to the right, the bigger the numbers are going to be. So let's just say that the meters was counting by ones. Then in this case, it would be 1, 2, 3 meters worth of cotton for $1. But the nylon would be like 6 meters of nylon for $1. So the nylon rope would be longer, and the graph shows that the greater length of nylon rope can be purchased for the same price as a shorter length of cotton rope. All right, another scenario. Noah and Diego left the amusement park's ticket booth at the same time. I wonder if they ran into Tyler. Probably the same amusement park, but each moved at a constant speed toward his favorite ride. Let's just say it's the bumper cars. I don't know. Doesn't matter. After 8 seconds, though, Noah was 17 meters from the ticket booth. Diego was 43 meters away from the ticket booth. Two questions, guys. Which line represents the distance traveled by Noah, and which line represents the distance traveled by Diego? So we're going to label each line. Which one is Noah? Which one is Diego? We don't know, right? By the way, pay attention to the graph right here, okay? The elapsed time, as more seconds go by, it's going to go to the right as more seconds. And as you go up higher and higher, this is the amount of distance traveled increasing. So the higher you go, the more distance that has been traveled, okay? So whatever line we choose, if this is Diego or Noah, we got to label it, but we have to also explain why we decided that the line represents that person's travel, okay? All right, so the steeper line in this case is going to represent the distance traveled by Diego. Here's why, all right? The reason is this. Let's say that this is where 8 seconds is. Okay, maybe it is, maybe it isn't. But if I moved the line, it's going to be the same situation that right here at 8 seconds, this is the distance traveled by Noah. I'd have to go a lot higher for that 8 seconds to get to Diego's distance traveled. And the further you go up on the distance traveled, the more distance that is being traveled. So right here, it's the same spot, 8 seconds, but Diego has traveled further, okay? All right, so Diego had gone further after 8 seconds, and if you pick a time and look at which line represents a person who's gone farther, that's the steeper graph. So that has to be Diego's line.